Everyone, welcome to my programming club. Today we will be solving another daily lead code problem, and the problem's name is number of ways to divide a long corridor. So the problem statement goes like this: a long library corridor. In a long library corridor, there is a line of seats and decorative plants. So the seats and the decorative plants are in a line, as you can see in this example. You are given a zero indexed string corridor of length n consisting of letters S and P, where S denotes a seat, okay, and P denotes a plant, okay. One room divider has already been installed to the left and to the very left and to the very right of the room. So as you can see, these black ones are the room dividers. There's a and that are being installed to the very left and to the very right of the room. Okay. Additional room dividers can also be installed for each position between indices. Basically, what you have to do is you have to place these additional dividers that are represented by blue here in such a way that each room is having exactly two seats. It can have any number of plants, but exactly two seats should be there in a room. Okay, and you should be returning that how many number of such combinations, or say how many number of such arrangements can be there, okay, of uh, different room sizes according to the blue partition that you will be placing. Okay, so you have to tell how many number of such arrangements can be there, uh, such that exactly two chairs are there in a room. Okay, and what you have to do is, uh, since the answer may be very large, you have to return it with respect to modulo 10 raised to power 9 plus 7. And if there is not a way that you can divide this whole corridor into segments of rooms in which there are exactly two chairs, then you will return 0 in that case. Okay, so for example, in this room, there was only one chair. So you will naturally return 0 as there are no such rooms possible, uh, such that all the rooms should be having exactly two chairs. In this there is only a single room possible, but that room will be having only single chair, so we will return 0. There is no way this corridor can be divided into rooms. So this is how we have to solve the. This is how we have to uh, uh, partition the room. Okay, and let's see how we will be approaching this problem. So let's say you take a sample test case or a some example here in which this string is given to you and you have to return the number of ways to partition this corridor. Okay, now if you observe that there should be at least two chairs in the room, so two chairs are fixed, and in between whatever the number of plants are sandwiched between rooms, there will be options to place partitions there. What I mean by this is, let's say this is the given example. Let's say this particular arrangement is given to you. Okay, now you were having options to place partitions here, here, or here. Okay, you cannot place a partition here because it is only one room of having two chairs. So once you have completed the room, then whatever is in between, whatever number of plants is in between these rooms, you can place partitions there. And if there are two plants, it can be observed that the number of partitions that can be placed, the number of places uh, partition can be placed is 2 plus 1 equal to 3. But there is a condition that these plants should be sandwiched between two rooms or between uh, two pair of chairs. Okay, so this is a sandwich one, so we will be counting this sandwiched between two chair rooms. But we are not counting this one because this is not sandwiched between two rooms. It is within the single room because uh, here two chairs have been formed, but the plant is in between them. Okay, we will only be counting the sandwiched plants between the rooms. Taking sandwiched plants into consideration for placing divider, or you can say partition. Okay, so this is the logic. This is a pretty straightforward logic. And also, let's say there was some another pair of chairs also. Let's say these were the chairs, and they were having some plants in between also. Let's say these were the plants, and these were three plants basically. So how many total number of ways to partition the whole corridor? That would have been, if you let's say place a partition here. So this partition can be combined with three of these partitions, three choices of partition here. Okay, so each of these partitions can be combined with three of them. So it will be nothing but, let's say this is x, x choices, and let's say this total is y choices. So total number of ways will be x into y. Okay, this is just combining these choices with the previous choices. So that's what we are doing, and that's pretty much it. And it is the logic of the problem. Okay, we will be solving it in a single traversal. So the time complexity of this solution will be order of n, where n will be the size of your string that is given to you, and space complexity wise it will be of 1 since we are not using any extra space. So let's see how the implementation goes. Anyhow, if you also want to have a look at the constraints, basically you have to look at the constraints if you are not doing any order of one solution. So n here is from range 1 to 10 is to power 5. Since we are using a approach that is giving us order of n solution, so we need not have to worry about the constraints here. Also, these constraints are not that much big, so we can easily solve it in order of n. Okay, so this is the approach. So what we are doing here is, as soon as you see a seat, S is here representing a seat. Okay, this S is representing seat and P is representing plant. So as soon as you see a seat, you will increment the seat count. Increment the seat count if you encounter a seat in the corridor. Initially, seat count will be initialized to 0. and SZ will be storing your size of the corridor. And this mode is what is being asked in the problem, that we have to return our answer with respect to this modulus. Okay. So as soon as we encounter a seat, we will increment the seat count. Okay. And then if your number of seats is odd and it's greater than 2, what I mean by this is uh, here the number of seat was odd, but it was not greater than 2. Okay. So here it will be odd and the number of seats will be greater than 2. What it means is we have arrived at a sandwiched uh, group of plants before this particular seat. Okay. So it means if this condition is satisfied, we have just passed a sandwiched group of plants which is eligible for placing partition uh, before the current index, current seat or say. Okay. So in that case, your total ways will be modified and total ways will be what is the previous seat index. Okay. So here in this example, the previous seat index is 1. So what was the index on which you have seen the last seat? Previous seat. Okay. Previous seat index here is 1 and you are currently doing calculations on index 4 while you are on index 4. Okay. Then in that case, how many number of dividers can you place here? It will be nothing but 4 minus 1, which is equal to 3. Okay. So why are we counting this seat number also? This seat? Because as you can see, for 2 plants we can place 3 dividers. That's why I am counting it. Okay. So that's the logic here. And once you have done that, you will keep changing your previous seat that you have encountered, previous seat index. And if there are at last the number of seats is even, and also it should be greater than 0. Okay. So it should not be like that there are 0 seats in the rooms that you have made till now, and it should be greater than 0 and there are more than 2, there are even number of seats. In that case you can make the arrangement, otherwise you cannot make. For example, here the number of seats were odd. Okay. And also if you take another example, let's say there are 3 seats, one is having a valid arrangement. Okay. So these are the plants. Okay. And there is another seat also. So in that case, you will be able to put these 2 seats in a room, but this seat cannot be put in a room since it will be requiring one more seat. We are required to exactly put 2 seats. So whenever the number of seats is odd, your answer will be 0. Otherwise, you will return the total ways. Okay. And this, if you ask, is just modular arithmetic that I have used. And so, this is how we will be solving the problem. If you are still having any doubts, please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.